All right, so in some respects, we talked about scatter plots a little bit already in the first semester, but the idea of here's just like a map of some data of some variable. And like as you guys are looking at this, you can kind of see, or you guys tell me, what do you see when you look at this? Definitely increasing. Okay. Are they in perfectly straight line? All right. So if I asked you guys to describe how far away are they from being on a straight line, or what would be the best line to fit them, that gets a little bit like, that's an uncomfortable question to answer. Right? If I asked you guys that, would it make you uneasy if I said, how close are they to being on a straight line? Pretty close, very close. It's hard to kind of quantify that. Are you with me? Okay, so both of these are like what I would say hard to quantify. And essentially the stuff we're going to learn in Unit 9 is how to do it. Okay, how do you quantify like what the best line is? For instance, I could draw this best fitting line. And what do you guys think? Does that come kind of close? Is it better than, say, this one? Or this one? We're good with saying that one's a bad line, right? But between the red and the blue line, we're like, so essentially what is the best fitting line? How do we decide? There's really fancy ways to do it that are like, they're not necessarily super challenging, but they're super easy to make mistakes. Okay, in other words, what we look at is distance from the lines. We want the points to be as close to the lines as possible, so we're trying to minimize those combined distances. Okay, we want to make those distances as small as possible. But as I move closer to one point, I'm moving further for another, and there's like a balancing act there. Okay? All right. Now, so when we talk about how far from a line a point, or how far away they are from being on the same line, the fancy word for that is the word correlation. And which line are they closest to? The fancy word for that is line of best fit. And so like this is kind of an overview of the big ideas that I want you guys to be able to do by the end of Unit 11. Okay, the crux of what we're going to do today is correlation. Okay? All right. All right. So what we have here is a whole bunch of different scatter plots, right? Okay. And for instance, if I'm looking at this scatter plot, we could say, well, I'm definitely comfortable calling that one increasing. And in terms of like close to a line, right? Like we could estimate the line is right about here. And those points are kind of close. Whereas I look at this one, and I'm definitely calling this one decreasing. And if I ask, are these points close to a line, you would say really, really close. Okay? And each of these kind of have a varying degree of closeness to the line. Okay? Great. All right. So to measure this, we have a value called R. And R is what we call our correlation coefficient. And some things about R. It's always between -1 and 1. And if I were to say, look at this graph, this one in the top right, where we said negative and practically on the line, that would be R equals -1. if I look at this one, not all exactly on a line, but pretty close to a line, right? This one might be r equals 0.95. Okay, so if r is negative, if the lines are going down, or if the linear trend of the points is going down, negative relationship. Okay, and if they're going up positive, so that tells us, so this is decreasing, this is increasing. If we look at the next one I'm going to kind of focus in on is this one. Overall, do you guys see so the bottom right? Overall, is this one increasing or decreasing, do you think? Decreasing? Are we comfortable with that? But like, are we also comfortable saying that it's like not very strong? All right, so my R value will be negative because it's decreasing, but it's going to be pretty darn, like maybe it might be R equals 0.15, negative 0.15. It's going to be close to 0. So R equals 0 would mean no relationship. There's no correlation between the two variables. Okay. Now, when you're looking at these, like if I'm looking at, say, this one, right? This one is pretty nebulous. Like, this looks like it's hard to see if something's going on or not, okay? One of the things you can do is approximate the means. So imagine that's the mean of my y coordinates and this is the mean of my x coordinates, okay? And if I did that on this graph, like if I did it up here, are you guys with me that all the points are in these two quadrants? These are my negative quadrants, okay? And these are my positive quadrants. So as I'm looking at, say, this one, we have more points in the negative quadrants than we do in the positive ones. And that's how I can tell that it's more negative than positive. Whereas in this one, I think it's about the same all the way through, right? So this one might be like R equals 0. Is this giving you guys a good idea of like how to judge what R is? Now, there are ways to calculate R. It is incredibly tedious. It's like first you have to find each point, you have to find the z-score of the x-coordinate and then the z-score of the y-coordinate, and then multiply those, and then take the average of all those products. It's not a single one of the calculations is a challenging calculation, but there's so many of them that it's just cumbersome. So your calculator is going to tell you R and R squared. Well, we'll talk about R squared later, tomorrow, okay? Like your calculator will give you all these values. It'll be more important to me that if I give you like, oh, the correlation of this data set is 0.95, what does that mean, okay? So there's two things when you interpret R. There's two things I want you to describe: strength and direction. So let's say well, we'll get to it. So, and then I want you to do that in context. So we'll get to an example in a few minutes here. All right, so that's the gist of correlation.